Okay guys, we're here working page 266, number 31. You can see 31, it gives you a graph that looks something like this. It's my best recreation, not exact. But we can answer letters A, B, C, and D from it. So first we're going to look at letter A. It says estimate the x-coordinate of every turning point and determine if those coordinates are relative maxima or relative minima. So if we're looking at this, we have three turning points. We have one here, we have one here, we have one here. Remember, a turning point is when the graph stops decreasing and begins to increase, or stops increasing and begins to decrease, and going that way. So we have to estimate this. So we can draw a little line, and that looks like we're going to have at a negative 2.5 a relative min. And we can say it's relative min because this point is lower than the points around it. And a negative 0.5 for this one here is a relative max. And then it looks like we have another relative min at 1.5. Okay, so now we're looking at B. It says estimate the x-coordinate of every 0. So you can see we cross here at negative 1 and 0. And estimating, that's roughly negative 3.75 and then 3. And those are our estimates of 0, negative 3.75 for this one, negative 1, 0, and 3. And then C, it says determine the smallest possible degree of the function. So the smallest possible degree that this could be would be 4. That's because 1, we have 4 zeros. 1, 2, 3, 4. Right? 1, 2, 3, 4. But we also have 3 turning points. So in order to have 4 zeros and 3 turning points, the smallest degree is 4. And then D asks us to estimate the domain and range. So since this one has minimum values, we know our range is going to be limited. So y needs to be greater than or equal to a negative 3. And the domain, all real numbers. And that's problem number 31 from page 266.